So today we're going to go over the measurement lab. So the objectives of this lab will be to understand how to measure with these given tools, as well as learn how to calculate density and percent error. We're also going to be incorporating volume displacement, how to get volume from volume displacement, unit conversion, and significant figures. So the first part is getting the volume from these three figures. Basic shapes, we got a rectangular prism, sphere, and a cylinder. And we're going to be getting the volume by using these three different equations. So width times length times height for the rectangular prism, and then pi times diameter squared times length over 4 for the cylinder. And for the sphere, we have 4/3 pi r cubed. We will be getting these dimensions from using these three different tools. So the meter stick, obviously you guys have seen this before, the vernier caliper, and the micrometer. So the purpose of using these three different tools is to understand the resolution of them. As you can see here, the meter stick has a resolution of 1 millimeter. Then the vernier caliper has a resolution of 0.1 millimeters, and a micrometer is 100th of a millimeter. Obviously, you want to use these tools to measure different size objects. You want to use, for this rock, volume displacement to find the volume. Why? Because you obviously can't measure the dimensions of this rock. So to do that, we would fill this metal container up all the way until the water starts dripping from this nozzle here. Once that water level is reached, you also want to make sure that the container is on a level surface. Then you can place this graduated cylinder under the nozzle to make sure you're catching the water that comes out after you drop this rock in. Water level will raise this volume. So then you'll catch the water out of the graduated cylinder. And in the graduated cylinder, you have ticks that measure milliliters. Each milliliter is equal to 1 centimeter cubed. Once you get the volume, then you would use a triple beam balance, this thing here, to find the mass of each object. And then once you have the mass and the volume, then you can calculate density here by using this equation, mass over volume. Once you get that density, there are given densities in your lab manual that have accepted values. These accepted values can be compared to your experimental value by this percent error calculation. Here's your experimental value, then your accepted value here and here. Then you just multiply it by 100%. All right, so now we're moved on to the procedure portion of experiment 1, measurements. So I'm going to give you an example of how you would have measured these objects in lab if you were here. First off, you would use a meter stick. So I'm going to be measuring the diameter of this iron sphere. On the meter stick, it would read about 1.5 centimeters. Okay, so then we would move on to the vernier caliper. So this diameter reads 1.905 centimeters, a lot more accurate than the meter stick. And then we would move on to the micrometer, which should have a lot more accuracy. And we are at about 19.11 millimeters, which means 1.911 centimeters. So after we get those measurements, then we would measure the mass of the object. Okay, so the mass would be about 28.4 grams. So now you get the density from that by dividing the volume the mass by the volume. You get the volume directly from the diameter. Just divide the diameter by 2, then you have the radius, and then you can use the volume for a sphere equation, 4/3 pi r cubed. Moving on to our irregular object, to find the volume, we would need to do the volume displacement trick. Let it drip until it does not drip anymore. Now that the water has stopped dripping, we catch the volume displaced. Once I put this rock in. And there we have it. It's about 13 milliliters or 13 centimeters cubed. And then we would find the mass using the triple beam balance once again. That is all. Thank you. Have a nice day.